Hey you guys, I'm going to go through the chapter review. I still, as always, suggest that you pause it, try it on your own, see what you got. Okay, there are just a few of these on your test. You are going to answer with only one of these words. It will be always, sometimes, or never. They're kind of hard. You need to think for a second before you do them, okay? These aren't too bad. They're pretty straightforward. The ones on the test, you're going to have to think. They're more like letter C. Remember, you've got all parallelograms with all of the traits. Parallelograms have two children. You've got your rhombus. All four sides are equal, and the diagonals bisect each opposite angles. And the diagonals are perpendicular to each other. They make 90 degrees. They make 90-degree angles, okay? You also have rectangles. When you're doing rectangles, they do not bisect opposite angles, but the diagonals are congruent to each other. So I'm just quickly reviewing these. Okay, the diagonals are congruent. They get together, they have the square, and the square has everything, okay? This is a mama, she's got her 5 traits, opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles are supplementary, which means they total 180, and the diagonals bisect each other. So you have all 5 of those traits. They should be in your notes and they should be on your reference sheet. The rhombus inherits every single trait of its parent. The rectangle inherits every single trait of the parent. So a rectangle is a parallelogram. All of this stuff is true. A rhombus is a parallelogram, so all of this is true, plus its own special theorems. Diagonal plus its own special theorem. Now you've got a square. A square is a parallelogram. A square is a rhombus. I'll just write out the word. And a square is a rectangle, okay? So the square has everything true about it. So is a square a parallelogram? Always. Always true. Is a rectangle a square? A rectangle could look like this. A rectangle has 4 right angles. A square is a special rectangle, a specific type of rectangle. So could a rectangle look like this? Yep. Could a rectangle, well, let's put right angles on here. Could a rectangle be a square and have 4 congruent sides? Yes. So this is sometimes. Sometimes yeah, sometimes no. Okay, the diagonals of a rhombus are congruent. Well, if I take my rhombus could look real flat. Okay? And it's pretty obvious here. The diagonals are not congruent. All 4 sides are congruent, but this is a pretty flat rhombus. If I make the rhombus like this, now they could be congruent, and in this situation, this is a square. So the only time the diagonals of a rhombus are congruent is if that rhombus is a square. So this also would be sometimes. Okay, here we go. If you're going to guess, everything is going to be part equals part. Now, it's not true for every question, but it's always a good guess. Okay, it says find the value of x. I'm talking about this angle right here, and I'm talking about this angle up here. So when I look at this, these are my 2 parallel sides. This is my transversal. These are alternate interior angles, which are congruent. So this will be a part equals part. So my equation is 2x equals 4x minus, I think that says 40. subtracting 4x, subtracting 4x. I would not subtract 2x. That will leave 0 on the left side, and a lot of kids mess up with that. Now divide by -2, and you get x is 20. And that makes sense. If this is, okay, 40, 4 times 20 is 80, 80 minus 40 is 40. That works. Okay, and then 2 times 20 is 40. Yep, that works. Okay, this one, we have A, B, C, D is a parallelogram. The length, this means from A to E, this is referring to length, is 2x plus 4. That's just from A to E. From A to C, this is only halfway. Okay, I'm only going from A to E. But when I talk about, so here's A to E, right? Only half of it. Okay, but then the next statement says from A to C is 40. That now is the whole entire length. Okay, so I either have to double A to E or take half of AC. So I'm going to say then if AC is 40, the diagonals bisect each other, which means they go through each other's midpoint. Half equals half. So if AC equals 40, that means A to E equals 20. This one you got to be careful on. It's a tricker. So 2x plus 14 equals 20. Subtract your 14. You want the x to isolate, right? That's 6 divided by 2, and x is equal to a 3. Okay? If I substitute that back in, 2 times 3 is 6. 6 plus 14 is 20. This is 20, so this would be 20. The whole thing is 40. So I did well. Okay, find the value of x so that the quadrilateral is a parallelogram. In order for it to be a parallelogram, both pairs of opposite sides have to be congruent. Well, I guess I could do either one. They should all come out to be the same. 2x equals x plus 8, or I could have done x equals 3x minus 16. Okay? Remember, you don't want to subtract 2x. You will have 0 on this side. That's always a big mistake. I have 2 x's. I take away 1 x. That means I have 1 x left. So x is equal to 8. If I had done this one, again, I would not subtract x. I'm going to subtract 3x. I get negative 2x equals negative 16. Either way, I've got x equals 8. That's my equation. If I plug this in just to check, this side would be 8 long. 8 times 3 is 24. 24 minus 16, yep, that's 8 long. Put 8 up here. 2 times 8 is 16. And then 8 plus 8 is 16. It makes sense. It works. Okay, let's do the next one. ABCD is a rectangle. First thing I'm going to do is sketch it. Remember, once you start naming it, you have to stay in order. So I'm going to go A, B. I cannot go C here. I have to go A, B, C, D. If you don't, you're going to mess it up. It says from A to C is 3x plus 11. That's talking about a diagonal. From B to D is x plus 7. This is a rectangle. And if you remember, okay, oops, I gotta shut that out. Okay, for rectangles, diagonals are congruent. Okay? So 3x minus 11 equals x plus 7. And then divide by 2, and you're going to get x equals 9. Okay? Now this one down here, we got to look at sides, and we got to look at angles. This is a parallelogram. Both pairs of opposite sides are parallel, so I know it's a parallelogram. Okay? What do I know is true? Opposite angles are congruent, both pairs. So when I look at this one, oh man, I'm killing my markers here. Hold on, guys. So I'm going to look at opposite angles. When it talks about degrees, we're talking about angles. When we talk about opposite, we're talking boxing corners. You're in a boxing ring. Opposite means boxing corner opposite, okay? So I've got 2x equals 50. Opposite angles are equal, are congruent. Divide by 2, x is 25. Okay? So it asks me what's the measure of angle J. So 2 times 25, that's 50. Okay? And I knew that anyways, because if this one's 50, this one's 50. Okay, if you also remember, if you have parallel lines cut by a transversal, then you're saying that I'm getting a different marker. Okay, sorry. You're saying consecutive same side interior angles are congruent. Consecutive interior, right? Those, not congruent, they total 180. They're supplementary. If it's like this, it's angle plus angle equals 180. So I'm doing now, if measure of angle J is 50, what's the measure of angle K, right? These are consecutive. They're not boxing corners, they're consecutive. They share this one ray, it kind of overlaps here, okay? So this means that the measure of angle J plus the measure of angle K equals 180. Well, I know J is 50, so this angle here has to be 180. So subtract 50, and this is 130. If measure of angle K is 130, boxing corners, opposite, measure of angle M is 130. Okay, if angle L is 50, we already saw that in the picture. Okay, here it says, what is the length from L to M? Well, if this one's 18, this one's 18. Opposite sides are congruent, right? Opposite angles, opposite sides. So, but we also have to find out what is Y. So we're going to say this side equals this side. Notice these are sides this time. 18 equals Y plus 3, subtract 3, Y is 15. Okay, there's your front page. Back side. Okay, first thing we're going to do is draw it. The diagonals of a square intersect at E. So I'm doing a square, A, B, C, D. Because it's a square, all four sides are equal, so it's a rhombus, right? And it's a rectangle. Square, rhombus. So all the theorems for rhombus is true, the definition is true, and all the theorems for a rectangle are true. Okay? And it's parallelogram. Throw that one in there. Okay, the square is a special guy. So they intersect here. This point right there is E. You don't have to draw the point. When they intersect, you know it is a point. From A to C, this is a diagonal. It's x minus 2. And B to E, this is only halfway, is half of a diagonal, right? Okay, so look again what we've got. We've got A to C, this whole thing is x minus 2, right here. Okay? But then we're looking, B to E is only halfway there. From B to E, this length from B to E. Okay, that much. Sorry about that black. Okay, that is half of it, which is x minus 16. We're going to have to double this one. So we got to double it. So A to C, the whole thing, this diagonal equals this diagonal because it's a rectangle. Diagonals of a rectangle are congruent. So if this whole thing equals this whole thing, this is only half of it, x minus 16. I've got to multiply x minus 16 by 2 to make it the full length. And then use your distributive property. Get your x's together. Don't lose that negative 2 when you bring it down. And then add your 30 over, add your 32, I'm sorry. And you're going to get x equals 30. Okay? So that's what x is equal to. The question is, how long is A to C? I wrote over it. So A to C is this here, x minus 2. So 30 minus 2 is 28. Okay? If I were to substitute this 30 in here, I get 14, which is half. 14 plus 14 is 28. So I did okay. Okay, I've got a parallelogram. Okay, because it's a parallelogram, I could only do the theorems for a parallelogram. In this case, am I talking about, you always have to think, are you talking about diagonals or sides or angles? Which one are you talking about? Diagonal, sides, or angles? In this case, I'm talking about diagonals. Because it's a parallelogram, I know the diagonals bisect each other. Okay? So that each part equals each other. So I could go 4w minus 7 equals, I got two of these, okay? 4w, this half, equals this half. Minus 7 equals 2w plus 3, solve it. And you could also do this half here equals this half here. Okay, 3b plus 1 equals 2b plus 5. So solve both of those to get those. Okay, this one also, you've got a parallelogram again. These are, it says it's a parallelogram. I know that the opposite corner, think a boxing ring. These would be opposite corners. Opposite angles are congruent. So that means y plus 10 equals 2y minus 40. This one's a little bit harder. Solve for y, substitute y back in, and then you're going to have to look at this angle and remember that consecutive angles are supplementary. So you're going to go angle plus angle equals 180. Once you find y, go ahead and do this. Find what y equals, then find what the measure of angle A equals. Then you can find the measure of angle B. Okay, that takes care of 8 and 9. I'll have the answers all the way worked out in the classroom, but you guys try some. Okay? Here, you're given this rectangle. It's a rectangle. Diagonals are congruent to each other, and a rectangle is a parallelogram with 4 right angles. P is the intersection. I'm going to draw it. It's a rectangle, so I know I've got 90-degree angles. I'm going to start W, X, Y, Z. P is the intersection. Okay? It says P to Y is equal to 3x minus 5. And then W to P is 2x plus 11. These halves equal each other. In a rectangle, the diagonals are equal lengths and the diagonals bisect each other. Because this, say if this was 10 and this is 10 and they bisect each other, that would mean they're all 5. They're all equal parts. Okay? So we're going to do part equals part. 3x minus 5 equals 2x plus 11. Solve for x, and then substitute back in how long is ZP. Okay, this one, Z to Y is 4x minus 9. W to X is 2x plus 5. This time we're talking about sides. This one, we were talking about diagonals. This one, we're talking about opposite sides. And I know that opposite sides are equal. So I've got 4x minus 9 equals 2x plus 5. Go ahead, solve for x. Substitute back in to find what is the length of WX. Almost there. Okay, number 11. This one's, I think, the harder one. Okay, given that ABCD is a rhombus, think about a rhombus. We got diagonals are perpendicular, diagonals bisect opposite angles, and you've got all 4 sides are congruent, okay? So measure of angle 3 is 40 degrees, okay? Now when you look at this, you could also, if you can't remember the stuff, just remember this. You've got a isosceles triangle up here. Okay, because it's isosceles, base angles are equal. And you have an isosceles triangle down here. Okay, because it's an isosceles triangle, base angles are equal. And these two triangles are equal to each other by side, side, side. So really, that's why you get the diagonals bisect opposite angles. So this triangle is a flip of this. These two triangles are congruent. So this angle is 40. This angle over here is 40. This angle here is 40. This angle here is 40. These are perpendicular. Diagonals are perpendicular to each other. So this is 90, 90, 90, 90. Okay? Now I have to find angle 4 right here. So I know that the golden rule for triangles, when you add the angles together, it is always 180. So if this is 90, this one up here is 40. This one I have to find. So I go angle plus angle plus angle equals 180 degrees. Okay? Angle plus angle plus angle equals 180. And then solve for 4. Last one. We're going to use the same information again. ABCD is a rhombus. Okay, same picture. ABCD is a rhombus. Angle BCD is 2x plus 3. Okay, so this whole angle, B to C to D, that angle is 2x plus 3. Then it says, what is the measure of angle ABC? A to B to C, okay? Are these, we're talking about angles. Now, are they opposite angles or adjacent angles? Consecutive angles. They're not adjacent, they're consecutive. These are consecutive. They're not opposite. They're not in the opposite corners of a boxing ring. Okay, these are consecutive. So on this one here, you're thinking parallel lines, transversal, consecutive angles, same side interior. They always add up to be 180. So when you're doing this one is not part equals part. It is not part equals part, okay? This one is angle plus angle equals 180. So you're doing 2x plus 3 plus 2x minus 7 equals 180. And then you're going to, that's your equation. You're going to solve for x. Once you get what x equals, you substitute the x in. What is the measure of each angle? Okay, add like terms. They're on the same side. You just do what it says. Positive 3 minus 7 minus 4. Okay, so I've got my equation was 2x plus 3 plus 2x minus 7 equals 180. I solved it. I got x is 46. I substitute that in to measure of angle BCD. This 46 replaces the x. 2 times 46 plus 3. Okay, and here you're going to also replace with 46, or you could think supplementary angles. Okay, that's it. Good luck with you finishing up. Let me know if you have questions. Thanks, you guys.